Welcome to Session 2, the BBC Microbit, Sensors, Radio, and Bluetooth, with Aldrin Torres and Marty Stone, Hacemos Atlanta volunteers.
I'm going to talk about the buttons. So the Microbit has 3 buttons, 2 in the front and 1 in the back. The most common use will be the 2 in the front. These buttons are inputs. All computers will have buttons like your volume control, your power button. The Microbit will have these 2 buttons to play around with your device as an input device. Then we have the reset button on the back. This will allow us to reset your program that you have on your Microbit. So we'll start over again from the beginning. Okay, let's see how we can program our device. Ready? Okay, we have screen. Let me clean this one out so we can start from over. All right, very simple. Let's go to inputs. Of course, the button is an input device, so I'll go to inputs. I click on button A, and I'll pick something really quick. Let's go show icon. So whenever I press button A, it will show the icon heart, or I can change it to a smiley face. All right, let's try on your simulator. There we go. I have a happy face. Let's try another button. Let's see if we can do button A. All right, so it's great. That means I can have 2 blocks using the same buttons. Let's switch to button B. There you go. And now we can have another thing to add. Let's show a number. When I press button B, I will show a number, up with 2. All right, I will see in my simulator how it works. Button B works. Perfect. So I'm showing on button A a smiley face, and button 2, number 2. One last button. Let's see. We can press button A once and button B on the other side, but we can press those together. Let's try again. I'll grab this one and I select the 2 buttons to say together. Very well. All right, so I will show a string. If I press together, I will say hi. Okay, ready? You will see an extra button in the simulator called A and B. But in your regular Microbit, you have to press those with your own hands. Okay, let's give it a try. Hi. Very good. And this is the end of this button session recording. I'm going to
In this section, we're going to talk about the 25 LEDs that are on your BBC Microbit. LED stands for Light Emitting Diode. These are little lights that act very much like a regular light bulb, except with a regular light bulb, the current, the electricity, can go either way. In a diode, or a light emitting diode, the electricity can only go in one direction. This can be very useful. It's kind of like a valve. Now, in addition to the fact that you can make all kinds of little icons and emojis with just 25 little LEDs, these little LEDs can also detect light, which makes it really great for doing writing programs where you might need to do something if you detect some light or if the light has been blocked. And we'll show you a quick program on how that works. So here we go. We're going to start at the microbit.org website. We're going to click on Let's Code. We're going to click on the Make Code Editor. I've already created a project called Light Level. All right, so how do we figure out how much light we've got showing up on our Microbit? Well, the first thing we're going to do is we're going to set up a variable, and I already have one called light available. You can call it whatever you want. And when you make a variable, it automatically creates these other blocks right here, set light available to 0 and change light available by 1. Well, we created a variable, and again, you just make a variable and you give it a name. In this case, again, I called it light available. You can call it whatever you want. The first thing I'm going to do is I'm going to take this and I'm going to take set light available to 0 and I'm going to put that on the start. I want to make sure that we kind of initialize the light available variable to 0. That gives it a clean start. Alright, so then the next thing I want to do is I want to say, oh, light level. Okay, that's on input. So maybe I can set light level, put light available, set light available to the light level. That's great. Perfect. All right. Well, that's fine. So I'm reading the light level and I'm giving the light, that information, and I'm putting it into the light available variable. Well, it'd be sure nice to see what that says. So we're going to go here. It's going to be in a number. So show number 0? No. We want to show the number light available. We want to show the number that's in light available. And then just because the computer runs very, very fast and does a lot of things very quickly, we want to kind of slow it down a little bit. And we're going to say delay 2 seconds. So what have we done? First, we've created a variable. Again, you can call it anything. You can call it light level. Even though that's a name already here, you can just call it light level. I'm calling it light available, and I'm setting it to 0 when we start. And then in my forever loop, I'm going to read the light level and take that information and put it into the variable light available. And then I'm going to show that number, and I'm going to pause for 2 seconds. Now over here on our Microbit, you can see that it's saying 128. Now, I can increase the light level or I can decrease the light level with this little cursor right here, and it changes the number. That's just like if I were to shine a flashlight on here. It goes all the way up from 255 and all the way down to 0. 0 is complete darkness, and 255 is the brightest light that it can detect. Alright, so it starts off about on 128, which is kind of in the middle, and that's fine. So what I'm going to do is I'm going to download or save this program. Alright. And then I'm going to take that program, it's now this light level 1 here, and I'm going to drag and drop it onto my Microbit. Alright, so I'm going to change screens in just a second, and we'll show you how the Microbit will respond to light. Alright, so now my Microbit is programmed, and we're going to go ahead and shift screens. So I'll be with you in just a minute. Alright, here is my programmed Microbit with the program that I just loaded to it called Light Level. And as you can see, the light in the room is kind of low. It's only showing up as, well, a 19 now. I'm going to go ahead and take my smartphone and turn on the flashlight. And I'm going to shine the flashlight on it. And now you can see that it's gone up to 154, 138. I can get right up close to it, and it gets 220 something. So you can see now if I take the light away, it's now back to 18. And so not only can the Microbit display light with the LEDs, but it can also detect light with the LEDs. And if I can make it even darker by putting my hands around it. Now it's just down to 6. 8. Take my hand away, and the light level goes up a little bit. So that's very handy. So again, in addition to having a device that shows light, the LEDs can also detect light. So you have a light sensor as well.
Right now I'm going to talk about the compass on your Microbit. Okay, so your Microbit has a compass sensor called magnetometer that measures magnetic fields. It can sense the Earth magnetic field, and so you can use it as a compass. When you first use the Microbit compass, you have to calibrate it. A little game appears on the screen where you have to tilt the Microbit to beat light to every LED. Then you're ready to go. If you see my screen, we have all 360 degrees about the rotation of the Earth. So if it's 0, it's pointing north. If it's in between 350 degrees and 45, remember this one, will be north for us. in this our exercise. If it's between 45 and 135, will be our east. And if it's 135 and 225, will be our south. And lastly, the rest will be west. Okay, let's do our code on the Microbit. Go open your browser, and we're here in our loop. So first, I want to create the variable, which will be the degrees of the compass. So if you see, you can type here and build your degrees. Okay, already exists, so it's already there. Okay, so then you put this set degrees to something. So I'll put it on the loop. So let's see the inputs. The magnetic field has some inputs, so that will be our next look for in input section. So it will be compass heading. So I'll put compass heading. There we go. So set degrees to compass heading. But we don't have anything. What you have seen in the Microbit is that we have a little thing pointing the direction. If you see, you can rotate and you go follow all the way around. You see the numbers changing all the way to 360 and then repeat to 0. All right, and start over from 0. Perfect. All right, let's figure it out. Then we have to create a loop. Okay, let's do a logic. We have it here, and this logic has a plus button, so we need to have 3 other sections because we can do north, east, south, west. Okay, so that will be 4 options. In this logic, we have to compare 2 degrees between 315 and 45. Remember that. So let's do a logic and a compare here, and or. So let's put it here. I'll put it in this section. I'll put it here in that side first. Then another logic here, another comparison tool. We're going to compare first 350 degrees, and then another one here. All right. So stop the recording and see if we can have this. All right. Let's put another degrees option here. So if degrees is in between 315 or degrees is less than 45, and put it all together here. Then let's put something about a string. So let's do a show string, and we'll do show north. Okay, perfect. Let's see on our Microbit. If I show here, it moves to north. Perfect. Let's do the other one. So let's do for the east. So I'll just copy this one. If it's Control C, I'll copy it. Copy it here. Else. So I'll put here. Oh, we have to do our comparison. So I'll do another logic here and add if. I have to do it here. Sorry. And I'll put it here. So 45 plus 30 plus 90 will be 135. Perfect. And copy this one, another string. So this is our east. Show east. Perfect. Now if you rotate here, you show east. Let's go to the next one. So one more. Control C, Control V, and then add it here. If it's 225, so 135 plus 90 is 225. So that will be west. So let's add more. Show string and put it here. That will be south. Okay. And the rest will be west. Let's do it. Perfect. Let's see if our code works. I'll rotate. It's going pointing east. All right, now it's south. Look at it. Now it's going west. Perfect. And then it's north. You can pause the video and try your own. See you in the next video. Right now I'm going to...
This next video is going to show you how the accelerometer on your Microbit works using an accelerometer that someone built with Legos.
How does a phone know which way you're holding it? Seriously, how does it know to rotate the image so it's always right side up? There's gotta be something in here that does that. If I'm driving and I want to know how fast I'm going, I can look at my speedometer. My speed tells me the distance I'll travel for a given amount of time. For example, 100 kilometers per hour means that in 1 hour, I'll travel 100 kilometers. Acceleration, however, is the measure of how fast my speed changes. It might take a high-end sports car 3 seconds to accelerate from 0 to 100 kilometers per hour. You would feel this acceleration by being thrown against your seat. There are a few ways to measure acceleration. One popular method relies on Newton's first law of motion. Summarized, this law says that a body at rest will remain at rest unless acted upon by an outside force, and a body in motion will remain in motion unless acted upon by an outside force. In a car, you don't necessarily feel the acceleration. The car is trying to accelerate and your body wants to stay in place, so you feel the car pinning you against your seat. We can use these principles to measure acceleration, and of course, I have a Lego demo for this. Our oversized accelerometer consists of a springy lever arm attached to a stationary structure. I've put the whole demo at the end of this rotating arm along with a camera that moves with it. As we accelerate in one direction, the lever arm will move away from the base. If we accelerate in the other direction, the lever arm moves toward the base, just like our person in the car. Now, let's add 2 conductive plates to the movable lever arm and the stationary arm. 2 parallel plates that are close together can store energy in an electric field. This type of energy storage device is known as a capacitor. The good news is that we can measure capacitance. As the plates move closer together, the capacitance increases, and as they move farther away, the capacitance decreases. I can't really swing all these parts around, but I hope this gives you an idea of how we can measure acceleration using electronics. And, of course, with all things electronics, humans have managed to figure out how to make this whole measurement setup very small, like really, really small. This tiny chip on the back of the Microbit is an accelerometer. It packs microscopic versions of the lever arms and a way to measure capacitance, just like in our larger demo. In fact, it can measure acceleration in all 3 dimensions. That includes acceleration left to right, front to back, and up and down. Accelerometers can be found in all sorts of things. For example, many modern cars use accelerometers to detect a crash and then deploy airbags to help keep passengers safe. Lots of video games in recent years use accelerometer data as a form of input. And biologists are starting to use accelerometers to help track the movements and behaviors of some animals. Back to the original phone question, how does my phone know which way I'm holding it? Well, Einstein showed that gravity is not a force. It is a field that imparts acceleration on all objects. Centuries before Einstein, Galileo is said to have tested this by dropping objects of different masses off the Leaning Tower of Pisa. During the Apollo 15 mission, Commander David Scott repeated Galileo's experiment by dropping a hammer and a feather on the moon to show that objects with different masses will accelerate and fall at the same rate, so long as there's no air resistance. That means we can measure the acceleration imparted on an object by gravity using our accelerometer. When I put my makeshift accelerometer upright on the table, you can see how gravity is pulling the lever arm down toward the base. If we flip it over, you can see gravity pulling the lever arm away from the base, and we can measure that difference. Because most modern cell phones have accelerometers, we can write software that responds to whichever way it thinks gravity is pulling it. This software then tells the screen to always flip to the upright position. With the Microbit, we can play around with an accelerometer and make some fun projects. To start, we'll just display a random number whenever we shake the Microbit. In MakeCode, go to Input and drag an OnShake block to your workspace. Whenever you physically shake the Microbit, the accelerometer will detect this motion and run code found within this block. In BASIC, drag a show number block to on shake. In math, drag a pick random block to show number and replace the default 0 value. Change the random numbers to 1 and 6. Download your code and copy it to your Microbit. Now, when you physically shake your Microbit, it should display a random number between 1 and 6. You can use a few of these together to make a set of virtual dice for your next board game. Accelerometers can be a lot of fun to play with, but they're also extremely useful for scientific measurements and safety in our everyday lives. I now hope you understand the gravity of the situation.
Microbit sensors. Today I'm going to talk about the temperature sensor that we have on the Microbit. Here, okay? All right, this way. So a temperature sensor is an input device that measures temperature. Your BBC Microbit has a temperature sensor inside a processor which can give you an approximation of the air temperature. So let's see how it works on your Microbit. Ready? So I'm going to remove this one. I want to clean it, and let's go to some basic. All right, let's go to the forever. Very simple. It's an input, so we need to get this input out. So if you check on the input, you will find temperature. So we'll have it here. So, but how are you going to provide this information out from the Microbit? So let's go to the basic input. So put show string, and then we'll put here on the forever. See, that works. So now it's showing all the time at the temperature, but I want to control that. I want to show that all the time. So I will just put it out or put it on the input. So I'll go on button A that you learned before. I'll put it here. Perfect. Let's see how it goes. If I click the A button, it will show the temperature. All right. If you see in the simulator, you have 21 degrees. I will move it up and see that shows the temperature 37 degrees. Voila, you see that change. So if you can tell, temperature can measure between cold and hot. So I'll make it colder, it will be 2 degrees. And that's it. You have built your Microbit as a temperature sensor. Thank you, and I'll see you in the next video. Microbit sensors.
In this lesson, we're going to introduce you to the Microbit radio and Bluetooth functions. All right, well, we're going to go ahead and start, as usual, at the Microbit homepage. We're going to click on Let's Code. We'll click on the Make Code Editor. I have an untitled project here with nothing in it that we're going to use. Now, when you're working with the Microbit radio, it's basically the Microbit is going to communicate from one Microbit to another. If you only have one Microbit, that's okay. You can still use the simulation down here, the simulation feature that will allow you to use 2 simulated Microbits. So we're working with the radio. Clicking on the radio shows that there are a lot of different functions available. The first one that you see here says Radio Set Group. This is pretty much setting the channel. Okay, the channel that the 2 Microbits will communicate on. So we're going to go ahead and grab that and put that in the on start. We always want to set our radio group. It can be from 0 actually all the way to 255. So you can have up to 256 different channels. So we'll go ahead and set radio group to 1. Now, we're going to make a very simple program that just communicates two numbers between 2 Microbits. So the next thing we're going to do is we can do a radio send number. So we'll do a radio send number when we push a button. So let's go to Input. On button A pressed, we'll put that there. And on button A pressed, we're going to send a number. The number we're going to send is the number 1. And on button B pressed, we're going to send the number 2. Okay, very simple. But at least we're going to communicate a couple of different things from one Microbit to another. All right, so let's go back to radio. we show here on radio received number. Well, yes, we're sending a number, so we'll also be wanting to receive it. Now, both microbits are going to have the exact same program on them. Okay, so on radio received, well, what are we going to do? We have some logic here, and we're going to use this if. Okay, and we also need to use this right here. Okay, if, and we need to make a copy of this. If received number is equal to 1, then we're going to just display. We're going to show a string. And we'll say hello in this case. So if received number is equal to 1, then we're going to show a string that says hello. All right, let's try this again. Radio, on radio received number. And we're just going to go ahead and copy this whole block, duplicate it. That's great. If received number is equal to 2, we're going to say goodbye. That's it. Pretty simple program. Although this does not seem to be working. Radio received number equals 2. I have an idea. Let's do this. Else show string goodbye. All right. So there's only two possibilities. The number can be a 1 or the number can be a 2. If received number is equal to 1, show string hello. We can also, if we want, actually, we can add a thing here and add another one. And what we can do here is copy this block, duplicate it, put it here. Received number is equal to 2. We can say show string goodbye. Now if it's not 1 or a 2, we have an error. So we can show string error. We'll never see this, but it's possible that there might be some sort of issue with the way the data was sent, so we'll do this anyways. Alright, now if we come over here to our microbit, the moment I click on this button, another microbit shows up. What if I hit 1? Well, the other microbit says hello. And if I click over here, this microbit will say hello. So these two microbits are transmitting back and forth to each other. If I click on the B button, it's going to say goodbye. And same with this. If I click on this button over here, it will say goodbye as well. Now notice there's only two possibilities, a 1 or a 2. Now what's interesting here is that we can actually do something a little different. Actually, we can say unbutton, we can make an error actually. Unbutton A and B pressed, radio send number 3. It's not going to be a 1 or a 2, is it? And so we have button A gives us a 1, button B gives us a 2, and if we press button A and B at the same time, we get a 3. Notice that a 1 gives you hello, a 2 gives you goodbye, and anything else will give you an error. Alright, let's try this again. Alright, as you can see, we've got our little board here. If I press A, it's going to say hello. And if I press B, it's going to say goodbye. But if I press both A and B buttons together, which is this button here, look at that, we get an error. Just like it was programmed. So with this, you can actually send data and messages between two microbits. Pretty neat, huh? Alright, now you get an opportunity to use the radio or Bluetooth, but you cannot use both. And so what I'm going to do is we're going to save this right here, call it radio. Alright, and we're just going to save it. Okay, and that's fine. Now I'm going to go back and we're going to make a new project. So we're going to come to the Make Code Editor, and in this case we want to use our Bluetooth. Now Bluetooth is also a radio, but it doesn't communicate between two microbits. Instead, the Bluetooth radio will communicate with your smartphone. So we're going to make a new project. Now you'll see here that Bluetooth does not show up in all of the function blocks that we have. So what do? Well, you come over here to this little gear, and there's a thing called extensions. And this is where you add in extensions or additional functions for anything that does not show up there. And look, we have Bluetooth services that we can add. When we add those Bluetooth services, the radio function is no longer available. So you only get one or the other. You either get the radio that communicates between one microbit and the other, or you get Bluetooth services, which allows your microbit to communicate with, well, anything running Bluetooth, but especially your smartphone. So we'll go ahead and add in the Bluetooth, and as you will see, it says some extensions will be removed. Extension radio is incompatible with Bluetooth. Remove radio and add Bluetooth? Yes, that's exactly what we're going to do. Alright, now that Bluetooth has been added, we now have a Bluetooth block with lots of Bluetooth functions. Bluetooth, by the way, is rather complicated service, rather complicated system. One of the great things, though, that we have here is that we can send accelerometer values, we can send button values. The I/O pins, that's on the edge where all the pins are down here. These are all little pins. We can send data out through there. We can deal with the LEDs through Bluetooth, the temperature sensor, we can send that kind of information, and even the magnetometer. So Bluetooth has to be connected, and once it's connected, it will eventually be disconnected. There's advertising. That lets one device know that the other device is there. And you can also advertise devices with an internet link. Clicking on the More shows that we have something called a UART. That's a Universal Asynchronous Receive and Transmit. It's just basically receiver and transmitter. We can write numbers, we can write strings, we can write lines. We can also stop advertising. That just lets the other Bluetooth device know that you're no longer available. And you can set the transmit power, how much power you are going to send. The more power, the further away you can be between Bluetooth devices. Alright, now what we're going to do is, there is actually a section here in the Microbit that talks about Bluetooth apps and examples. And there are a lot of great apps and examples that allow the Microbit to talk to a smartphone over BLE, which is Bluetooth Low Energy. Well, let's take a look here. We got iOS apps on iTunes. So here there's a Microbit app, all right, that you can download if you have an iPhone. And in doing that, it walks you through and lets you know how you can communicate. Again, you can send data like the accelerometer that tells you, the orientation of your Microbit. You can send compass data. There is just lots of stuff here that you can send. All right, so basically you compare with any number of microbits. So that's the Microbit app. It lets you compare with microbits. You can actually program your phone through this application. I'm sorry, you can program your Microbit through your phone. And so this is a free program that you can download. There's also Android app that allows you to use Bluetooth with your Android app, and it's basically here that you would install on your Android phone.
For the quick tour of the Microbit sensors, using the Microbit and code with those. I hope you have learned something about the LEDs, that you can detect light, and how to measure with your Microbit using the code blocks. Also the magnetometer and compass, how to measure the magnetic field from the Earth and pointing north, south, and identifying those numbers using your Microbit. We also learned about the accelerometer, how you can shake this little device and provide very accurate information about your Microbit. We also have learned about how to read the temperature using your Microbit. Just remember that temperature is in Celsius. If you want to change to Fahrenheit, you have to use the math and add it in your Microbit. The other option we have reviewed is also the radio and Bluetooth options. Those are very important if you're interested to use that radio to communicate to the other Microbits, or Bluetooth if you want to upload your code using your Bluetooth. So I hope with these lessons you're eager to learn more about the sensors you have in your Microbit. This little powerful device can do anything for you if you have a lot of creativity. So keep going. For the quick tour